these things, if you draw the sine curve, right, and then use that to find the derivative of this by looking at the slopes. I'm going to show you by this, not that one. Okay, so this is the sine curve. The red line shows you the slope of that sine curve. I'll move this point along here, right, and it's going to trace out what the slope is. The slope starts at 1. And the slope is going down, so that red curve is going down, right? The slope gets down to about there. And now the slope is 0 right there. Right? The line is horizontal, so the red curve has gone down here. This is the graph of the derivative. If you keep going with this is, oops, why won't that let me do that? Come on. Oh, come on. It's not that hard. I don't know why it always does that. Stop the video. Okay, well, I just won't let go of it now. Bad drawing. Then it keeps going here, right? Snaps to that point. And then it's going to be at its minimum right there. That's where it's -1, and then it turns around and starts to go back up again. 0 there, and it's just going to alternate between those things, right? Go really fast. So it's just alternating, right? The slope is going up. It's a roller coaster, up, down, right? So the red line is telling you what the slope is, right? The red curve tells you your speed, like of how that is changing. It tells you how the graph of the black curve is changing, right? At this point, when you switch from, say, there to there, the slope is negative, the black curve's going down, so the derivative's negative. And then you get to here, the black curve starts to go back up again, the derivative's positive. What is that a graph of, that red curve? It's cosine, right? The derivative of sine is cosine. When you went through and graphed that, you should have discovered that derivative of sine is cosine. Derivative of cosine is, it'd be really nice if this worked out where it was a nice reciprocal arrangement, right? Derivative of cosine. Hey, want to be my derivative? Yeah, I'll be your derivative too, but it's not quite that way, right? It's just not that way. You know, want to be my friend? Okay, I'll be your friend too. Oh, sorry. I mean, it should be your negative friend. It just doesn't work out the way it should, right? Once you know that, this is something you should remember, okay? This is the first, hey, listen please. This is the first derivative we've come across that doesn't follow that, the rule, right? The power rule. This is ones you just have to know. You can use them here. This gets people all messed up though when there's other things involved. You can follow everything else the same way. If you have 3 pieces all added together, find the derivative of each one. If you want to do the derivative of 2, well, it's like if we're doing y prime here, derivative of 2 is 0. You don't even need it there. Derivative of 3 times a function, you could just leave the 3 out of it, right? The 3 in front of a function, like the derivative of 3 times f of x is 3 times whatever the derivative of f of x is. It's like you can pull this out, right, if it's a constant times a function. So the derivative of 3 sine x is 3 cos x. The derivative of minus cos is what? Is positive sine. Right? Or you could think of it like this and put minus sine, which is plus sine, right? So it's 3 cos x plus sine x, however you end up writing it. What kind of rule are you going to need to use here? Yeah, the product rule, because you got 2 things multiplied. What are you going to need to use here? Yeah, you need to use the quotient rule here. Quotient rule. You're going to need to use the quotient rule here as well. Sometimes later on here you can use some trig identities and stuff, but don't think that you'll always have to use trig identities.